So let's talk about rearranging equations. Let's pretend for a moment that we're dealing with a really common equation that a lot of people know. Let's say we're wanting to know the velocity. And we want to know the average velocity over time. And to calculate that, we often use the formula V for velocity is equal to the amount of distance that we're going to travel, so our D, divided by how long it took to travel that distance. So divided by, we'll call that T. Now, this is a very common formula that a lot of people know and use all the time. But sometimes we're not so interested in calculating the average velocity something's traveling at. But rather than maybe how long it might take to travel somewhere, if we're able to travel that average velocity and we know the distance. So, for example, let's say I wanted to know how long it might take to travel somewhere if our average velocity over the period of time was, say, I don't know, 85 kilometers per hour. And the total distance that we're trying to travel here is, say, 700 kilometers. Now, I want to know how long will it take for me to arrive at my destination if I'm going to average 85 kilometers per hour and my distance is 700 kilometers. Well, one way we could do it is we could just substitute V and D in and solve for T. That is one way that we could do it. But let's say I haven't just got one of these calculations. I've got many of these calculations I want to do. Or I want to put in some kind of formula into a computer and maybe get the computer to quickly do it myself. Well, to do that, we actually need to rearrange this equation. And we want to rearrange it to make, instead of V equals, we want it T equals something. So our time is equal. And we call that making T the subject of this equation. So let's do that here. Let's rearrange this to make T the subject instead of V being the subject. Well, because we're dividing by T at the moment, if I want to remove that T from the bottom of the fraction, I would need to do the opposite of dividing by T, which is to multiply by T here. And these two will cancel each other out. But to keep an equation balanced, I'll also need to multiply the other side of the equation, so the left-hand side of the equation, by T. So what that enables me to say is that velocity times T, so Vt, is going to be equal to my distance, or D. So in essence what I'm saying here is if I want to calculate this distance that I've travelled, I can take the average velocity that I've travelled at and multiply it by time, which kind of makes sense. So what I've done now is I've made D our subject. I haven't quite made T our subject. So to make T our subject, I need to do one more step. Because I'm multiplying by V, I'll need to divide by V to cancel this V out on the left-hand side. But whatever I do to one side of the equation, I must do to the other to keep it balanced. So we'll divide that side by V as well. And what that will leave us here is with T equals, which is what we're after, because now T is the subject of our equation. And T is going to be equal to the total distance that we travelled divided by the velocity that we're travelling at. Now, some of you might have played around with this equation many times before and already knew that to work out the time it would take, you'd just do the distance divided by the average velocity that you're travelling at. But this is just learning a process at the moment. So right now I've got my T as the subject. So what I can do with my original problem now is I can just substitute my distance of 700 and my velocity of 85 and work out what T is. So the total time in this problem here would be equal to 700, because that was my distance, divided by my velocity of 85. And when we do that, we'll work out that T is approximately equal to, I'm just checking my calculator here, is approximately equal to 8.82, and time would be in hours here. So approximately 8.82 hours. So that's an example of how we might rearrange this formula to make T the subject. But let's play around with one more formula. Let's consider, say, the area of a circle formula. So we know that to calculate the area of a circle, and we'll use A to represent that we would multiply pi by the radius squared. So to calculate the area of the circle would be equal to pi r squared. And let's say that I wanted to create a circle with an area that was equal to 50 square centimeters. I want to know what my radius would have to be for a circle that had an area of 50 squared centimeters. Well, essentially what I want to do here to make that happen is I want to rearrange this equation here to make r the subject. So at the moment in this equation, my area, so my a, is the subject of the equation. So to rearrange this, I need to strip away this pi and the squaring to get r to be the subject of my equation. So the first thing I will need to strip back is going to be this pi, not the squared first, the pi. So because this pi is multiplying by r squared, I will need to divide this side by pi to cancel it out. But whatever I do to one side to keep the equation balanced, I will need to do it to the other side. So what that will leave me is, these pi's cancel. So it will leave me with r squared is equal to the area divided by pi. Now, I've got the r squared on its own. So r isn't the subject yet because I'm still squaring that r. So what I need to do is I need to cancel this squaring out. And to do that, I'll need to square root this side here because the square root of r squared will just be r. But whatever I do to one side of the equation, I must do to the other. So I must also square root the left-hand side of the equation here. And now what I've done here, once I've done this step, is I've got the r on its own. So I'm going to write r in the left-hand side here. And it's going to be equal to this square root of the area divided by pi. So my radius is going to be equal to the square root of my area divided by pi. And this has now created an equation that I can use to quickly find the radius of a circle for whatever area that I'm wanting to find it for. But in my question, I wanted to find the radius for when it was 50 centimeters squared. So to do that, I'll just need to substitute my a of 50. So my radius here for my circle will be equal to the square root of 50, because that's my area, divided by pi. Now, when I put that into a calculator, what you'll find is it'll be approximately, our radius will be approximately equal to 4 centimeters. It's slightly less than 4 centimeters, like 3.989 or something like that, but it's approximately 4 centimeters. So if you create a circle with a radius of approximately 4 centimeters, you approximately have an area of 50 squared centimeters. Now, what's really important here is you can do this with any equation that you have. You can rearrange any equation that you've got to make a different variable or different letter the subject of your equation. And it's a very useful skill to be able to have.